product development cannot succeed without additive manufacturing. Where it can help is in the tooling and part production are the two areas where there's significant growth and where we're going to see the biggest impact for additive manufacturing in the years to come.
So on that point, what are some of the barriers to entry into that type of market?
Education is a barrier. There's a challenge in front of us, not within the institutions, in the academics, and within the commercial world, as having an understanding of what additive manufacturing can do for you. Everyone went to school today understanding the traditional manufacturing means. So there's a lot of excitement about the technology, but there's still a lot to learn about how to best leverage those capabilities.
One of the challenges with a lot of the manufacturing having gone overseas the past 10, 15, 20 years, a lot of that education has left the curriculum. We didn't teach part specification and we didn't have hands-on machining classes. They'd all gone. Guess what? We need those back now.
Most of us here are always thinking of the reforming, always thinking engineering education reform. And one thing that we would like to have is the more flexible curriculum, innovative curriculum, curriculum that teach our students problem solving. And all these, from the implementation point of view, is necessary to have the design process from the first semester. And I think that this tool or technology help us to have more project-based hands-on curriculum development.
Certainly along with adding things into the curriculum, another thing that needs to be considered is giving students access to using this type of technology.
Well, there's a lot of excitement around this additive manufacturing. When the students see it, they can see that part or that product fairly quickly. And so some of us are trying to get those devices in the curriculum. We have to kind of integrate it throughout the curriculum, get them started early on. This equipment, some of it, at least the smaller modeling, isn't that expensive.
Key partners within the industry have to get involved to support that initiative, and the sooner we define some standards around it as well, I think it's very important, then that will accelerate the adoption or understanding of additive manufacturing within the institutions.
Even with the traditional manufacturing processes, you see standards developed around designing products and how to actually carry out these manufacturing processes, so it only seems natural for standards to be developed on the additive manufacturing front as well.
There are definitely lots of efforts underway looking at standards. ASTM has their, the F42 subcommittee is looking specifically for additive manufacturing. I know NIST has several efforts underway as well, trying to get it to understand just really the capabilities and the variation that you're seeing in these processes. We've done some work having 3 or 4 different vendors printing the same part, and what comes back is drastically different on the same machine with supposedly the same material and the same process parameters. If we're going to really adopt this to print parts that are going onto planes and cars and whatnot, we need to be able to understand where are those sources of variation and then how do we control them. And standards, I think, are going to be a key in defining that and helping set the course for us.
Certainly, if you don't injection mold something the same way every time, it's not going to turn out the same way. So you kind of have to develop standards around that.
Discussions revolve around yield rates. They want consistency, reliability, the same performance expectations that we are offered through traditional manufacturing.
This is now is an exciting time because now we can collaborate with economy and industry on these elements. And by the way, the additive manufacturing is 20 years old, and in the new technology, 20 years old is a young technology. So it is 20 years and we achieve this important steps. So there are a lot of things, and I'm telling for the new, that for the students, for the researchers, these are the exciting challenges and exciting research topics that we can discuss and we can come up with.
And I think the academics play a critical role for that, because industry doesn't have the time to figure this out, and they don't want to spend the time figuring it out because they have their time to market demands on them today. So within the institutions, within the industry, or the manufacturers of this technology, working collaboratively together to figure it out.
In addition to those industry partnerships, which are critical for this, we got to figure out how do we cut across these silos, because the interplay between all these different things is so tightly coupled. Even we're talking to folks in supply chain, and how is this going to disrupt what it's going to do to supply chains for companies if now you can print on demand wherever you are.
We're seeing a lot of redundancy. A lot of my clients are involved in aerospace. They're all going through the same initiatives. One organization gets those parts certified for flight. The next organization is starting and doing that process all over again. So it's continuing because there are no standards. So once it gets approved, certified, we should be able to leverage that information and baseline for other organizations. So let's open up the book. It should all be there, and they shouldn't have to worry about going through that certification process every time they manufacture a part. So it's very important.